One pile of pencils has more than another. Move just 2 pencils across, from the bigger pile to the smaller, and suddenly the 2 piles are equal. So how many more did the first pile start with? It is very tempting to say 2, simply matching the 2 you moved. That answer feels obvious, and it is wrong. The mistake is watching the pencils instead of the difference. To see what really happened, do not stare at the piles. Look hard at the gap between them. Put real numbers on it. Say pile A has 10 pencils and pile B has 6. The gap between them is 4. That gap of 4 is the thing we are really tracking, so keep your eye on it. Now move 2 pencils from A to B pile. A drops from 10 to 8, and the very same 2 pencils land in B, lifting it from 6 to 8. Watch both bars meet in the middle. 8 and 8, the 2 bars meet exactly level. It worked, and moving 2 really did make them equal. But look carefully at what it took to get there, because the how is the whole lesson. Moving 2 did 2 things at once. It took 2 off pile A, and it added 2 onto pile B, so the gap did not shrink by 2, it shrank by 2 plus 2, a full 4, from 4 down to 0. For the gap to close all the way down to 0, it must have started at 4 in the first place. So pile A began with 4 more than B, not 2. The 2 you moved was never the difference. It was only half of it because it worked on both piles at once. This is the whole insight, and it works for any amount. Move n across, and the giver loses n while the receiver gains n. The 2 piles march toward each other from both sides at once, so the gap between them changes by 2n, double what you moved. Turn that around, and it becomes a tool you can use. To even 2 piles up, you give away exactly half the gap. Half, not the whole thing, because your one move quietly counts twice, once on each side. That halving is the trap and the shortcut, both at once. It matters that this is a transfer, not just a removal. If you only took 2 off pile A and threw them away, the gap would change by just 2 one-sided. Pile B never moved. But a transfer hands those 2 straight to B, so B climbs at the same moment A falls. That second half, the receiver rising to meet the giver, is exactly what doubles the effect on the gap. Give and take together, not just take. That is why the answer was 4 and not 2. So whenever something crosses from one side to another, watch the gap, not the amount. A transfer is two-sided. It lowers one and raises the other, so it always moves the gap by double what you carried. Read a problem that way and it stops being confusing. To close a gap, move half of it. To find the starting gap, take what was moved and double it. One insight and the puzzle falls open. Your turn. This time, moving 6 pencils across makes the 2 piles equal. How many more did the giving pile start with? Remember, watch the gap, pause and answer. Moving 6 drops the giver by 6 and lifts the other by 6 at the same time, so the gap closes by 12, not 6. For that to reach 0, the gap must have started at 12. The giver had 12 more to begin with, double the 6 you moved. Same trap, same fix. One more, the other way round. 2 piles differ by 10. How many pencils do you move across to make them exactly equal? Use half the gap, pause and try. Move half the gap, which is 5. Those 5 come off the bigger pile and land on the smaller, closing the whole 10. Not 10, just 5, because every pencil you move counts on both sides. This shows up anytime something leaves one side and joins another. Sharing sweets fairly, balancing a scale, leveling 2 stacks, moving money between accounts. The transfer always hits both sides, so the gap always moves double. Watch the gap, not the amount. So when things move between 2 sides, do not match the amount to the difference. A transfer is two-sided, so it changes the gap by double. To level 2 piles, give away half the gap and let each move count twice. That's all for this video.